How to program. This video is about teaching you how to program. I've watched a lot of online videos, and I don't think any of them know what they're doing. And I probably don't either, but we'll look at it. So how do we program? So this is multiple choice question. Is it picking a language? That's the important thing to do. How to create a loop. Most of these online coding application videos tell you that somehow you have to create a loop and this is the best way to do it. Or how to perform a conditional. How do we do that? How do we control flow control? Why is that important? Or is it learning object-oriented programming, which is how do we group functions to a data structure? Simple as that. We all do that. Every program, every application out there does that. That's what that does. Now, it may not look like it, but it's identical. Or functional programming. That's just simply a different form of assigning a function to a data structure. That's all functions do. Take information and do something with it. Or is it learning about programming patterns? Not even sure what a pattern is. I think my wife had some patterns when she picked out her dinnerware or something, but as far as programming, I've never seen one. Programming life cycle. How do we program? Is that really a thing? Is it some sort of step-by-step process? Is it learning how to type? Is that what programming is? There's a lot of it, I guarantee you, but I type with 2 fingers. I'm slow as Christmas. I can't spell worth a dang. But is that important? Is it to become a subject matter expert? Is that what programming is? Do we learn one thing and stay with that? Do we learn how to use an API? These are basically that's all we do really, is call functions. Is that the technology that we really want to know? Or do we want to learn artificial intelligence logic, some sort of thing that says this is something? I don't even know what that is either. I've been doing this 50 years and I don't really know what any of these things are. Or is it none of the above? So I would say it's none of the above. That's not what you want to really do in software development. If you're going to be a programmer, how do we program? So things to know when you're going to start. I'm talking no matter if this is day one of you wanting to learn to be a programmer or if you have 40 years experience. Computers, these are the things you need to know. Computers only perform actions. That's all we're really asking it to do. At the hardware level, we're asking it to add and subtract, compare things, and jump around. That's what computers do. And then we code in and go through loops and maybe do summations and compares and selections. And that's pretty much what computers do. All compilers, every one of them, perform the same actions. Then it's up to you as a programmer to get it to perform actions, and those actions are only performed on numbers. And every programmer loves to be on every tree, meaning that no one does something identical. And every programmer wants to not use somebody else's logic or someone else's syntax. Every language is a little bit different. They're all identical, but they're a little bit different because, I don't know, what was it? Python was using a star or something for a comment. I've done 50 different languages and they all confuse it. Slash or a C in column 1 is Fortran, or a billion other variations. And so is that. This is what you need to know when you start, or if you've been there for 40 years. And what you really want to know is do what the client needs, not what he wants. It's your job to know what he needs. He's going to ask you for something. I get a lot of projects and they always say I want this and this, and generally there's one line in there of what he really needs. And so it's up to you to know what he needs and not what he wants. And what benefit is it to the company? I mean, most programs don't last very long. You may write hundreds of thousands of applications and you may get 4 or 5 that actually are a benefit. And every dependency that you create or attach to your application, the operating system, the compilers have limitations, the Bootstrap has limitations, the device drivers have limitations, the communication has limitations, and when you tie these in, you're going to be dependent upon them. Being dependent on it means that you cannot surpass these limitations. So if something can only add 8-bit numbers, that's it. You cannot overcome that, not without eliminating that dependency. So we are literally in the Stone Age of software development. The Bronze Age started at 2000 BC, and we're just now. So what are you doing? What are we doing? So when you're programming, what exactly is it that you're trying to accomplish? You should not be trying to create an application. That's, I think, our biggest issue. We think we want this application. Is that what we really want to create? No, you should be creating a technology. And the difference between a technology and an application is technology is complete. It covers all aspects of that particular action. So if you're adding 2 numbers, it should add 2 numbers, period. Doesn't matter how many bits, doesn't matter whatever. It has no limitations. Once you put a limitation in there, it becomes an application. A format specification, a number of bits. These are all application specific, whether it's yours or somebody else's. And that's not what we should be creating. We should be creating technologies. Creating technologies are complete. And if it's not complete, it's just that we don't know how to fix it yet. But when we do determine that, then we have to have the ability to extend the technology for everybody. And so when you start your application or start determining some application that you're going to create or some technology, you need to start by knowing all your limitations. Where are the limitations coming in? And we have, I don't know of any application out there or any technology that we have, hardware or software, that doesn't have a limitation. So we have date is a duration. That's just pure stupidity. Numbers are limited. Again, number of bits. Fonts are one-dimensional. So we can't use them for 2-dimensional and 3-dimensional uses. Mathematics is 2-dimensional. CNC types of things is 3-dimensional. So we could take advantage. We could use, what I'm saying here is fonts. It's the same thing. It's a character. it's a representation of our spoken language or of a symbol or whatever it is, and it should be able to be defined once and used for a technology. Period. Once we do that, then we never have to. Then we can start writing editors and CNC and only never ever have to keep rebuilding the wheel. Okay, and all dependencies are someone else's design. So even your own. So you create a design, a subsystem. And that design is specific. Now when you try to add something else to that design, some use for it, If it wasn't intended, then most likely, well, you will be dependent upon it. And so you have to be careful. So here I want to look at an example. I could teach you how to do loops and conditionals and look at all the different languages. It's obnoxious since all languages, computer languages and scripting languages are all doing one thing. Do an action. Run this program, print this file. Let me browse this file and create me an HTML form, whatever it is. It's simply an action, a PDF document, whatever. Okay. So let's have a real life example. This is what I'm doing right now. So I thought, here's a good example of the process of my thinking, and it should be yours, of how to create and attack a issue, a problem. I want to create a library of knowledge. So let's create a CLIF library of knowledge. This is, since I'm building Jane, which is a system to maintain all knowledge universally. And the way we will do that is we have subroutines and variables and logic and information structures and books and documentation and we have knowledge. So we would like to classify that. We want to design a classification scheme for computers, which is mouse. That's a term. So we look at a library's classification purpose, and we can change the library's classification to school management system, self-driving cars. What we first determine what are we trying to accomplish. So in our classification scheme, we'd like to know where the book is. Okay, if this is a real library, we'll kind of put it in reality before we get to the computer, but we'd like to know where that piece of information is. Where is the logic that printed this document? How was this formatted, and how was it created, and who created it, and all this knowledge. We'd like that. So where is it? That's the first thing we want to know when we create a classification scheme. What's each book about? Here we know we have something. We know what it is. It's a mouse. But what's it for? Exactly. I mean, what in this context, in the context that we've defined it, we'd like to know what its purpose is, what it's about. And then we'd like to, in real libraries, we'd like to group books by discipline, context, subject, or idea. So Library of Congress uses groups book by discipline, which is a little bit different from context and subject matter, subject headings. Dewey Decimal classifies, groups things by subject headings. And or ideas are, and then we'd like to subgroup it by author and by title. These are Cutter numbers. This is part of the Library of Congress and Dewey classification system, which is if you have a large group, let's say math algebra books, and maybe there's 500 books on algebra alone, then you would like to somehow group them so that they're associated by author or maybe by title, so that, and then we create a card catalog. Okay, this is a separate entity that says, oh, this is where you look when you want to find, if you have a book. You may not be in the library, the card catalog could be anywhere, but generally they're located in the library, but they don't have to be, of course. And with the computers really destroyed library science, so I can't really say that the current library systems work very well. And then we'd like to sell card catalog cabinets. Okay, why did I put this in there? Dewey Decimal, everybody says, okay, Dewey Decimal was the first great library system. actually Dewey didn't design it for a cataloging system. He did it so he could sell card catalog cabinets. That's how he made his money, and sell the cards. So he was selling cards and card catalogs to all the libraries, and so he made money by doing that. And so if you ask me, between the cutter number and the card catalog cabinets, this was the real technology of library science. Because the bookshelves, yes, everybody had bookshelves before. Okay, so here we have a drawer, and with our cards in it, we can flip through, and all things would be organized so that if you're interested in algebra, you could look up that subject heading and mathematics algebra, and you would find it in all the books that more or less related to algebra. And then we'd like to make it easy to stock the shelves. When we get all of our books, or we get new books, we'd like to know where to put them before we get one. So we would build all our shelves, and then computers, we would design our storage system. And before we get the first piece of information, we'd like to have the definition of where we're going to put it before we get anything, or where we create new things. And we'd like to restock it so that in physical devices, it's pulled out by somebody, and we need to know where to put it back. So they get the little cards, they put all their books on, they roll around, they know exactly where that book goes, and it's perfectly organized. And I want to add one more thing to the above ones are for a physical library. Well, I want to incorporate book number into the card number. This way it's unique. By default, our cataloging systems are not unique, because you can have multiple call numbers on multiple books by multiple authors. So we want to look at the different types of classification schemes. We have Dewey Decimal. Like I said, he created this and published the first version in 1876. And before this, pretty much they organized, all libraries organized theirs alphabetically by title of the book. But generally these libraries were very small. It was getting that the libraries were getting much bigger. Then we have National Library of Medicine, which was very specific. They used Dewey, but they found that the medicine sections were not very well classified. Subject headings were not very detailed, so they came up and said, we'll create our own section for this, for our purpose only, but we'll still use Dewey. And part of that classification was a Cutter number. So Charles Cutter created this system. He organized one of the first libraries in the United States, and he found that if you have 500 books on one subject that were grouped, he needed to be able, there was no way to organize it. So he created the Cutter number, and that would internally, in one classification with 500 books, it would internally sort it by author's name and or by book title. And that way, if an author wrote a whole bunch of books, they'd all be organized together and so on. So depending upon the library, each library was different. And then we had Library of Congress, came in 1897, and this is the one currently with about 32 million books and periodicals, and I don't know if they include videos and all that, but there's a lot of things that they're cataloging. So it's a very, very large effort there. National Library of Medicine adopted Library of Congress classification, and so, but which they incorporated into their cataloging system, but their medicine kind of uses the syntax, but in actuality they don't. And then we have Universal Decimal Classification. This was, I think, Sweden or somewhere like that, Europe. And Russia has cataloged 28 million of their books into this system. And then we have Sears subject headings, which was done for libraries that were smaller than Dewey. And then we have a colon classification, which was done for India, and that's a very well-defined and accepted classification scheme for them. And then my library of knowledge, I want to create for computers, so that just like library of medicine, I want to use LC, and I want to use library of medicine classification. I want to use the library of medicine and LC together, and then add computers. So digital information classification, knowledge classification. So other classification schemes. We have a thesaurus, which came out in 1668. Actually, before 1668, every dictionary was actually called a thesaurus. But then when thesaurus came out, it said, when they used that in a particular mode, which was synonyms, which was basically a book of synonyms, it separated from dictionary. NASA uses this to catalog their projects. So every vendor that works for NASA I don't know if they still do, but 10 or 20 years ago they were forcing every project or every contract to make sure that their project was classified in the NASA thesaurus. Art classification, which is very difficult because of the multiple types of art, but are difficult, almost impossible to do that classification because city names change. Oh, this was done in London. Well, actually, London's name has changed from its first. Anyway, that's a whole another issue. Law libraries. Okay, Charles Cutter has said that the classification of books is properly based upon the book itself, rather than the classification of ideas. So, but law libraries, they use LC. Well, actually, they use all four basic library schemes, depending on the library. But things like the law library, it would be nice if it were possible to actually catalog each of the laws. But I don't think that's possible. And then we have plants, how they're organized and classified, and street addresses is a great classification. I think probably one of the best classifications we have. 7710 Janik, that tells me which house on what street, and then Houston, Texas. Actually, I'm the only. You look on Google and type in 7710 Janik, you only get my house in the world, or at least on Google. Exactly what you need to know to get to that particular entity, which is great. That's a great classification scheme, probably one of the best, because I can send letters anybody in the world, and I guess you could say the same for not really, but I'm not gonna go there. Animal classifications, township and range and section. This is a geographic classification, which is Kansas and those areas in which you have a large area, and then you split it up, and then that classification. The name itself tells you exactly where that's at geographically within the U.S. And then you have Bliss classification. These are just newer classifications that are used for different purposes. And Dickinson classification. This was for music libraries. and MARC records, which are uh, under Library of Congress and NLM. They use MARC records, which is basically a format that's supposed to be shared, be able to share the classification information, like the book author and the publisher and the date published and whether it has illustrations and basically whatever was on the card, the 3x5 card in the card catalog, which was probably, to me, the greatest invention ever, was besides the street address, was the 3x5 card. It was packed full of exactly what you needed to know, pretty much, before you even saw the book. So, LC call number example. Here's one out of Library of Congress. It's Intermediate Algebra by Sandra, Barbara, and Mary. So it had 3 authors. It was published in Boston under this publisher in 1998. That's the information. And so in the yellow is the Library of Congress call numbers. So QA in the Library of Congress is defined as mathematics. 154.2 is algebra textbooks advanced 1971 to 2000. It's kind of wrong because it says intermediate. Unfortunately, under the Library of Congress, they only have elementary and advanced. They have no intermediate classification for textbooks. So what do we do? Well, some librarians are going to classify this as elementary, and some are going to classify it as advanced. This is your problem, which means that you're trying to build something. Whatever application it is, you're going to find the exceptions to the rule. And one person, as I said, every programmer on every tree. And so this is never going to happen. So you have to be very dictatorship, and you have to be professional about it. You have to know exactly what ramifications are going to occur. Here, to me, this is here's a cutter number for Sandra, and the .C46 is taken from Sandra's last name. So C means it's Clarkson, and 4 is for the L, and 6 is for the R. This is a very, very unique and probably one of the best technologies I've seen in a long time. And I started thinking about this and thinking about Google. How have they been able to create their classification of all the material on the internet? And I think they're using a modified cutter number technology. When you look up and ask Google what did they use for their classification algorithms, and they just said, oh, we used all kinds of things. But there's always a fundamental basic technology to anything, no matter what it is. And I think, my personal view is, I think it was cutter number technology. Okay, and then it came to the year published. And so I took that and I said, okay, let me create a syntax that I can put in my language, every language actually, COBOL, Fortran, C, C++, whatever, and put it in there so that we can use this to pull up any piece of information or pull up that book. So we're using it as both as a call number for the book itself to be put on the book, and also as a book number so that it's unique. That's what I want to get to. So under my Cliff Library of Knowledge, this is the first part of this is REF is part of Library of Congress. I put the colon in there so I could not require blanks between each field. So I changed the format up a little bit so that we could do that. Ref is where in the library it is. Generally, it's in the general stack, but there's a reference area. And they've done this for CDs. If it's a CD, they put CD there. If it's a DVD, they put DVD. If it's a juvenile. And next, they put the discipline, mathematics, algebra, so that's their discipline. The Library of Congress does it by discipline. Dewey classifies their book as subject headings. So it's a fine separation there. But these are the things that you as a programmer have to know. You don't have to be a subject. You do not want to be a subject matter. You don't want to be a librarian. You just want to know your job. How do I format this thing so that it's a technology, not a particular application? Well, this library only has no volume number, so I won't put it in there. It's better to expand your logic or technology to cover everything, not just those things that the company requested. And I guarantee you, 2 weeks after you leave something out, or you ask 20 people and they say it's never done, I guarantee you it's done once. And that will kill your application. We get down to revision number, which means that you may have in computers, everything has revisions. This has been edited. I don't want to throw the old one away. I want to keep it. And so I put a revision number in there. We put that in there to make this a book number so that it's unique, globally unique. And then we put date. So I put the D there because there's a 3 and a 2. And so I want to be able to take the spaces out. And so I put a D there just saying, here's a date. And then I said, okay, look, it would be nice to be able to expand this. And this is what you're doing when you're programming. You're determining what your limitations are. You write the program so that it's not required that you never want anything required if at all possible. So if somebody says, well, it's like, here, enter our phone number. Okay, 1-800-FLOWERS. Or, I don't have the phone number. Susan, call Bob. He's got Jerry's phone number, which he may call his wife. If you want to put a whole book in there, who cares? It's not people worry too much about space and time and energy. I tell you what, you're wasting more of the client's time than anything else. And I guarantee you do not want to validate anything if you can possibly help it. And so back to my program, so I'll be able to put this reference number in there and get that book or allocate it or do it or find out everything I want to know about it. Okay, now we get to where since this is a technology and it's software, every user could create his own technology. This is what we want to be able to do. We want to be able to catalog. From my viewpoint, I want to catalog all software, which is great. But the end user may say, well, look, that's a great technology. Windows, when you load up Windows or boot to Windows, you got 15 billion files out there and DLLs and everything. I want all those classified so that when you come in here, you have one cell and then everything's cataloged properly. And I'd like to do that for Bob, who has a library of pictures. And so he types this in and says, oh, these are my pictures. This is my cataloging. Because everybody's going to have a different reason. Ford they may want to catalog all their parts, so that they can look at that number. And I'm sure they've done that internally. That's what cataloging is for. But we like to not have 15 billion applications doing different cataloging schemes. We want one technology that handles all classifications, even Bob's. So here he says, okay, P means pictures, 100 means holidays, 200 means vacations, 300 means events, landscapes, pets, and wildlife kind of thing. And then holidays at home, holidays at relatives. So Like P for pictures, 100.1 is pictures at home, January 2004. So I don't need to put the whole date. I don't, and so it would be in software. We can just go get those wherever they are. Or we don't care what pictures, we know the date it was done, and it'll go and find those. Or we could say it's on our backup. I want all pictures from my backup. And so you see we're looking at action requests that's already defined. And you can expand this and put in all kind of, you could put in a large language model if you wanted to on top of this. But the fundamental technology, I don't care how you say it, it's still the same thing. You have to have that technology and be very well defined. Once it's defined, you start coding and you're going to get to work. What I generally do is I hard code the hard logic first. Those things that have limitations. How am I able to get around them? If I can't, and 99% of the time, the logic you work with, the API, the operating system, the compiler, whatever it is that you're having to work with, if it's not yours, even if it is yours, you may have forgotten what it does. You have to figure out how to get it to work. So you do those things first, make sure it's all, if you're trying to do image analysis or something, find the cat in a picture, you want to first find out, can I get the picture? That's number one. Irrelevant of what you're doing, you want to, okay, can I get the picture? Let me write a 3-line program and get the picture. And does that fit my design for my technology? So that's where we want to go. And this is to see which parts of our design are possible and cost effective. It may be possible, but it's going to take me 14 weeks just to get the picture or video or whatever it is, or off the cloud or whatever it is, or security, or I don't have permissions, or a billion other reasons and that's what you want to look at first. How do you email? How do you get the permissions? How long is it going to take to get the permission? Do you even have access? I was working for one company, oil transmission pipeline, and I needed access to their intergraph maps, which are the maps for the 1,500 mile pipeline, 36-inch gas pipeline, and he wouldn't give it to me. I had one person that just says, look, I'm not going to give it to you. I said, I can't do my job. So I basically had to pack up my bag and leave. Basically, I can't, but that's what you're going to run into. And then what you want to do is you want to code your hello world test cases. So you find the hard parts, you see if you can do it, and do it in a, just do a very few as possible characters, crude as possible, but you just want to see if that's possible. And then these become test cases. So you build your test case for the hard parts as you get further and further, then your whole project goes very, very smoothly because you're hitting the hard parts first and you stop. You're not, I guess I shouldn't. I know this is a long dang video, but what I'm trying to say is that I was once, I've designed my system for 10 years, and it's taken so long, but I got to the, early in the stage, about the first year, 2 years, I said, okay, I know the part that I want. I need this part to organize, kind of part of this kind of philosophy, but kind of stuff. But I said, I need to be able to do this. I said, yes, I could create this. It'll take about 120,000 lines of code to do it. And I thought weeks and weeks and weeks. I said, okay, is that what I want to do? And I said, okay. And I almost started. I said, wait, let me go ahead and go a little further on this. And so I went and designed the system a little further. It took me another 6 months. And at the end of that 6 months, I didn't need that 120,000 lines of code. It was not necessary because of simple design changes that happen after you redesign things. So it's the design that's really you're looking at. It's not the coding. Once you've done that, you're good and happy with it, and you're satisfied that you know what you're doing. You determine the scope of how big your project is. Is this a technology or is this an application? If it's an application, you can just brute force everything, and which is what we do now. I've quit. I've been at this 50 years, and I quit doing applications. I will only do technologies from now on. So we determine the scope and the timetable that it's going to take, and that's where we're at. So we want to get to work, and this is, for me, this is how we should be designing our software. And worrying about loops and syntax and comments or not comments or a go-to statement or all these stupid little things that have no real bearing on the work we're really trying to accomplish. Thank you for your time, and have a great one. Bye now.